Hey everyone, it's Justin again. In this lesson, you're going to learn about two types of symmetry: line symmetry and rotational symmetry. We can see line symmetry in Mia's name, and rotational symmetry in this sun that Mia picked out. At the end of this lesson, you'll get to do an activity similar to what Mia did here, but we have some learning to do first. So let's get started. By the end of this lesson, you should be able to identify line symmetry and rotational symmetry. First, we'll learn about line symmetry by analyzing 4 pictures. Then, we'll learn about rotational symmetry by analyzing the same 4 pictures and learning some vocabulary along the way. Before you started this video, you should have printed the Symmetry Cutouts PDF and followed the directions to get your pictures ready. It'll be helpful in this lesson to refer to those cutouts as we go. You may draw on them, fold them, or whatever helps you visualize what we're learning about. So follow the directions on the Symmetry Cutouts PDF now if you haven't already. First, let's talk about line symmetry, otherwise known as reflectional symmetry. Let's start with this equilateral triangle inscribed in a circle. We need to find all the places where this has line symmetry. I can draw a line here and cover up the other half. Or, with the cutout you have in front of you, you can fold here. If I can reflect this half over the line and get the same exact picture I started with, then we have line symmetry. So here it goes. Yep, reflecting the left side over the line took us right back to the original picture. That's how we know that this is a line of symmetry. But this picture actually has 2 more lines of symmetry. Try to find the other 2 lines of symmetry for this image now. You can use the cutout you have for this picture to fold and draw on, and when you have your final answer, sketch it on your notes template. Let's see if you found the other 2. Here's another line of symmetry. See how both halves are a mirror image of the other? And here's the final one. This gives us a total of 3 lines of symmetry on this one figure. All right, it's your turn. I have a challenge for you. Try to find how many lines of symmetry each of these 3 pictures has. Use your cutouts first, and then draw the lines in on your notes template when you have your final answers. Remember that on any line of symmetry, the figure should be a mirror image of itself. Pause the video now and try this out. Let's talk about this Jamaican flag symmetry first. This horizontal line is definitely a line of symmetry because the top half is a mirror image of the bottom half. We also have a line of symmetry going vertically right through the middle. This vertical line is a line of symmetry because the right half is a mirror image of the left half. We found 2 lines of symmetry, but I'm wondering if you think there are any more. Let's try a line of symmetry going diagonally through this flag. If we take one side and reflect it over the line of symmetry, we do not get the other side back again. This doesn't look the same as the original flag, so we can say that this is not a line of symmetry. Overall, we can say that this flag has 2 lines of symmetry. And what about the other pictures you tried? Were you able to find all 8 lines of symmetry on this snowflake? These 4 lines of symmetry are probably the easier ones to notice because they go through the bigger tips of the snowflake. But there are 4 more going through the smaller tips of the snowflake too, giving us a total of 8. And finally, let's talk about this Liberian flag. Hopefully you're realizing this is a trick question because there aren't any lines of symmetry on this flag. And that's okay. Not everything has line symmetry. Let's take a look at rotational symmetry next. We're going to use the same pictures we used for line symmetry, but analyze them in a different way. First, we need to find the center of rotation. Just Find the middle and put a point there. This is the center of rotation and the point that we're going to rotate around. You can even try putting your pencil here. Then you would rotate your paper while your pencil keeps this point in the same spot. The next question is, can we rotate this picture and have it look exactly like it does now? And if so, how many times? Imagine taking this point where the triangle meets with the circle and turning the picture so the point moves over here. Or don't even imagine it. Use the picture you have in front of you and turn it yourself. Does it look exactly the same as it did to start with? Yeah, it does. We can even do that again. Take the same point and turn your paper again so the point lands here. It still looks like the same picture we started with. Doing this one more time would actually take the point back to where it started. This brings up two more vocabulary terms for us to talk about. The first new vocabulary term is the order. This is how many times we rotated to get back to the original picture. For this particular picture, we rotated 3 times to get back to the original, so the order is 3. We also need to learn about the magnitude. This is the angle that we rotated each time we made a turn. To figure this out, we take 360 and divide it by the order, which is 3 in this case. For this example, our magnitude is 120 degrees. Let me explain this a little more. Remember the center of rotation? Well, when we rotated this point, we did so at a 120 degree angle to the center of rotation. This just means that this angle is 120 degrees. All right, it's your turn once more. For each of these pictures, draw the center of rotation and find the order and magnitude. Pause the video now so you can do this with your cutouts, and when you're confident, copy your work into your notes template. Let's see how it went. The center of rotation for this Jamaican flag is right in the middle. We can pick a reference point to help us visualize the rotation, such as this one. If we rotate about the center 90 degrees, we might think we can stop here, but this is not the same picture we started with, so let's keep turning it. There we go. Now this flag looks like it did when we started. And we can turn it one more time to get it back to its starting position. This was only 2 turns where the flag looked exactly the same as the original, which means the order is 2. And the magnitude is 360 divided by 2, giving us 180 degrees. This means each turn we did was a 180 degree turn. Let's check your work on the other pictures as well. This snowflake could turn 8 times about its center of rotation and look just like the original. This means that its order is 8. And 360 degrees divided by 8 gives us a magnitude of 45 degrees, meaning each turn we did was a 45 degree turn. And finally, let's look at the Liberian flag once more. This is a trick question again. There's no way to rotate this so that it looks exactly the same as it does now, unless we rotate it a full 360 degrees back to its original position. That's kind of cheating, because you can technically do that with anything and everything. So let's just write no rotational symmetry and be done with it. Now you know all about line symmetry and rotational symmetry. Don't forget to finish your notes template and complete your activity for this lesson before starting your practice problems. You'll be doing something similar to what Mia made here. Have fun, be creative, and I'll see you next time.